This is Advanced Math, Unit 5, Lesson 3. Today's title is Trig Proofs. We're going to write here prove/verify. Those words are interchangeable. You'll see prove the following or verify the following. They mean the same thing when it comes to these type of problems. And these are not your typical two-column proofs that you learned back in Math 2 with the geometry type units. This is a little different. Okay, tan theta plus cotan theta equals secant theta cosecant theta. Tan theta plus cotangent theta equals secant theta times cosecant theta. Okay, when you're working these out, what you can and cannot do. You cannot move things around. Like I can't subtract cotangent over there or divide both sides by secant. I'm not solving. I'm proving, so I cannot move things around either side of the equal sign. Other thing, I pick only one side, and that is the only side I manipulate. I'm not going to manipulate this side, if I pick this side, I'm not going to manipulate this side, and vice versa. If I pick this side to change things around, I cannot touch this side. And at the end, I want them to equal each other. So, I'm going to pick this side, and I'll explain a little bit on how and why. But what I'm going to do is I'm going to take this, I'm going to use my identities, manipulate this, and change it to look like this in the end. Again, I'm going to take this, use my identities, manipulate it, change it, and make it look like this. Okay, why this side? You typically pick the side that is bigger. These two are kind of the same, but when you have like one that's a little more complicated, that's typically the one you pick because you can manipulate it a little better and condense it down to the smaller one. On this one, here is what my thought process is. I see this. Well, first off, I see there's no squared on either side. Can't use any identities. But I see this can be 1 over cosine theta times secant. Cosecant is 1 over sine theta. And if I were to do that, there's nothing left for me to do. If I multiply this, it's 1 over cosine sine. And I can't get that to look like this. So instead of picking this side, I'm going to do this side. This kind of stuff here I would kind of do in my head, and I think, okay, what is this? What is this? What would happen if I changed it? And in my head I would see, oh, that's not going to help me. All right, I'm going to cover that. We're not going to use it, but we are going to use it a little bit later. So for now, just ignore it, act like it's not there. We're working with this side. Okay, about the only thing I can do here is change everything to sine and cosine. And that is because there's no squared. So sine theta over cosine theta plus cosine theta over sine theta. And then when you look at this, you should recognize that only way I can add is if I have a common denominator. And the common denominator is going to be cosine theta times sine theta. Or sine theta, cosine theta. It doesn't matter how you write it. Okay, so I'm going to multiply the first fraction, top and bottom, by sine theta. Why? Because sine times cosine is the cosine sine. Sine times sine is sine squared theta. Plus, I'm going to multiply the second one, top and bottom, by cosine theta. Why cosine theta? Because sine times cosine is the cosine sine. Okay, cosine theta times cosine theta is cosine squared theta. Now I'm hoping you recognize right here, this should be screaming at you, change me, change me. Sine squared plus cosine squared is 1. So I'm left with 1 over cosine theta times sine theta. And I'm hoping now you can recognize, hey, that's kind of like what I have over here, just this is one fraction and this is two separate fractions. With multiplication, you can pull the fractions apart a little easier than you can when it's addition. When it's multiplication, 1 over cosine theta times 1 over sine theta. Can you see that these two things are equivalent? 1 over cosine times 1 over sine is equivalent to 1 over cosine sine. Same thing. All I did is I rewrote them as two separate fractions. The only reason I did that is to then say, hey, 1 over cosine is secant, 1 over sine is cosecant, and we're pretty much done. This is secant theta times 1 over sine is cosecant theta, and that equals what we're trying to prove, secant theta times cosecant theta. Okay, this is what your work, your homework should look like, your quizzes, your tests. In order for you to receive credit for this on the test, you've bubbled in the side you picked. You've only manipulated this side. This side I didn't manipulate. This is kind of just my thinking process. This is 1 over cosine, 1 over sine. And I worked this side out, and at the end, I get this to look exactly like this. Now, recognizing that what you've boxed in pretty much is just this equals itself. Now, this is not your answer. This is telling me you are done. This is not your answer because anybody can write, oh, secant theta, cosecant theta equals secant theta, cosecant theta, box it in and put junk in the middle. When I grade this, what I look for is that you've bubbled. This here is your answer. All of this here, this work is your answer. This here is telling me you are done. Bubble, box in for you being done, and this here is your answer. Your work is your answer. All right, let's try another one. Number 2. Sin x cosine x plus sine squared x over sin x equals cosine x plus sin x. So it's kind of like what we've been doing these last 2 days, only now we're telling you, hey, this is the answer. That's really the only difference. This is the answer. What can you do to get to the answer? So it's a little nicer because at least now you know what the answer is and you know what you're trying to change it to. All right, right side or left side? I would pick the one that's a little bigger, more complicated. So I would pick this one. I would like it if you guys would hit pause, try it on your own. Let me give you the one hint first. GCF this at the top. GCF, hit pause, try it on your own, and then hit play again and see if you come up with the same answer or the same work. Okay, GCF, sine x comes out, cosine x plus sine x, because sine times cosine is sine cosine, sine times sine is sine squared, all over sine x. And you can see here that that is going to reduce, leaving you with cosine x plus sine x, which is equal to what we have over here, cosine x plus sine x, and you're done. A little easier than the last one. Some are easy, some are not. Some take quite a bit more steps. But that's it. GCF'd it, reduced it, and we're left with what we were trying to get. Okay, number 3. Tan beta minus cotan beta equals tan squared beta minus cotangent squared beta all over tan beta plus cotangent beta. All right. So like the last one, I would pick the one that's a bit more complicated. I would pick this side here. All right. I'll give you the hint. Press pause, try it on your own, push play, and see if you have it correct. The hint is difference of two squares. Right here, that's difference of two squares. Factor, reduce, and see if you can get it to work. Go ahead and hit pause and try it now. Okay, hopefully you've tried it already. Tan beta plus cotangent beta, and then tan beta minus cotangent beta. If you don't like beta, you can change it to theta or x. I really don't care. Okay, tan beta plus cotangent beta, tan beta minus cotangent beta, because that's how difference of two squares works, all over tan beta plus cotangent beta. And we can see right here that this is going to reduce, gone and gone, leaving me with tan beta minus cotangent beta. And that's what I'm trying to prove. Tan beta minus cotangent beta. Again, this boxing in is not your answer. That's telling me you're done. This in here is your answer. Your work for these type of problems is your answer. Okay, number 4. 2 minus sine squared x equals 1 plus cosine squared x. When they're like this, it doesn't really matter which side you pick. Pick a side, go with it, and go and see what you end up with. Now, because I've seen these enough times, I can see I want to pick this one, because this one I would have to distribute a negative, and I'll show you what I mean in just a little bit. Okay, I'll pick this side and manipulate whatever I can manipulate. 1 plus cosine squared is not an identity. Do you see that? 1 minus cosine squared is an identity, but 1 plus cosine squared is not. Okay, so recognizing that first. Okay, 1 plus, but I am going to change cosine squared to its identity. Cosine squared, if I were to get cosine squared by itself, what would it equal? 1 minus sine squared. If I were to subtract this guy to the other side, cosine squared equals 1 minus sine squared. And that's pretty much it, if you can see it already. Again, 1 stayed 1, plus stayed plus, cosine squared became 1 minus sine squared. I'm going to just put this back in blue so you can see those two things are the same. And then I combine like terms. 1 plus 1 is 2. Take away sine squared x, and that equals what you're trying to prove. 2 minus sine squared x. Some are a lot easier, some do take a little more work. Okay, I'm going to cover this really quick. I will uncover in just a bit. I just wanted to show you that what if you did pick this side and not the right side? You would have 2 minus parentheses, and then you would change the sine squared to 1 minus cosine squared. And I need parentheses there because I'd have to distribute that negative. 2 take away 1 plus cosine squared x. 2 take away 1 is 1 plus cosine squared x equals that there. And it works out nicely either way. So on problems like this, you really just pick a side and go with it. So the only thing with this one is you have to remember to distribute the negative. Okay, moving on. Number 5. tan cubed x minus cotangent cubed x all over tan x minus cotangent x equals secant squared x plus cotangent squared x. All right, I'm hoping you recognize the left side would be the best place to start. It is a bit more complicated. I'm going to take a side note and remind you guys about cube factoring. Okay, that's the side I'm going to pick. Cube factoring, you do need to know for the test. I don't want to hear on test day, oh, I don't remember cube factoring. I'm warning you now, cube factoring, you do need to remember for the test. So I'm just going to write it right here. A cubed minus b cubed equals a minus b, a squared plus ab plus b squared. And if that had been a plus, then it would be plus minus plus. Same, opposite, always positive. AB, a squared, AB, b squared. All right. So, hoping everybody recognized that this up here is cube factoring. Tan cubed minus x minus cotangent cubed minus x. A is tan x. Why? Because tan to the third power is tangent cubed. Minus b is cotangent x. Why? Because cotangent to the third power is cotangent cubed x. Times a squared tangent squared x plus the product of a and b, tan x cotan x, plus b squared, that's b, cotangent squared x, all over tan x minus cotangent x. I'm going to remind you one more time, cube factoring is on the test. So put a little note here, test question. It's very similar to this one here. And oftentimes I have kids forget how to cube factor. This is why we spend that whole time on Unit 1 remembering how to factor and complex fractions and all that good stuff we did way back when. Okay, A is tangent, B is cotangent. AB, A squared, the product of A and B squared. Same, opposite, always positive. And the tan x minus cotangent x reduces. Now with this, you always want to keep your eye on what you're trying to get. I can see that I already have the cotangent squared x, the plus piece there. Can you see that? So the question then is, how can I get this piece right here to equal secant squared? Well, think about what you have here. Tangent squared is just tangent squared. But here, there's no squared, but tangent and cotangent are reciprocal functions, which means tangent's going to stay tangent, plus what does this guy right here become? What happens when you multiply reciprocal functions? It's 1. So you have tan squared x plus 1 plus cotangent squared x. Again, I don't want to touch the cotangents, the plus cotangent squared x, because I already have that there. But recognize that tan squared x plus 1 is an identity. Tan squared x plus 1 is secant squared. So this blue piece right here becomes secant squared x plus cotangent squared x, which is what we're trying to prove, equals secant squared x plus cotangent squared x. And that's it. I will tell you that kids do struggle with these the first few times through. It takes a while for them to become comfortable with them. And the hard part is it's not like solving an equation where you always subtract and then divide and move things over. There's really no steps where you always do this in this order. You kind of just think about it, try it out, see if it works. If it doesn't, scratch it and try again. We'll get more practice with this in class. And that is it for this lesson.